Oh, so this should be it, right? This should be it, right? Hmm?
That's your meeting.
This computer audio. Access.
Now you said yes to the guideline before. I don't know. I'm getting people to join.
So are you able to join?
I was. Let me go back to it.
Hello, hello.
Hello, Nika.
Yeah, no.
Oh, it's Ken. Okay, I see Engineer Shirley, but our other facilitators are not here yet. Please, let's make sure they have the right link.
Yes,
That's
Shinon.
Dr. Pranja. Dr.
Yes, yes.
Pranja and Mr. Ayodeji.
Okay.
Ken,
Ken.
My audio.
Ken, please make sure they have the right link so we can get started.
My audio.
Join audio now. Join audio. Join
All right.
Can you hear?
Yeah.
You're not supposed to talk, Sha. No, I have my presentation here. Okay. So when I say share screen, how do I? If you want to share screen. No. Okay. If you have to share screen, just go there. Share screen.
So Ken, please make sure that the other two facilitators have the right links. to join.
You disabled him from sharing screen.
More, right?
Where? No. Go to share screen. No, cancel. Go to participant. Okay. Panelist. That's him. No. Okay. Go here. Yeah, no, not there. Cancel. Wait, an icon will come up. Lucky. So we're making the code was can share the screen. So I try sharing now.
Okay. Yeah. Okay. So I'll go to
Okay.
share screen. Yeah.
So you choose the one you want to share.
Okay.
Click it again. So you go to presentation mode.
Yeah.
Okay. So zoom in, bend your screen a bit. Right.
Okay, Engineer Shirley, can you put your screen on presentation mode?
Yeah.
Ken needs to do that for you, to put it on presentation mode.
It's on presentation mode now.
Now it is, yes. Now we can see. Okay, let's get started. It's 10 o'clock. Good morning, everyone. Hello and welcome. I'm glad you could join us for this virtual masterclass on boilers. This is brought to you by Energy Training Center. Today, our guest facilitators will take us through 3 presentations. It is important that you are available to listen to all of our facilitators. And we're starting on schedule. We will keep to time. The first presentation is on boilers, the types, inspection, and operator's responsibility. The second will be on modern technology for boiler maintenance and troubleshooting. And the third will focus on opportunities for energy savings in boiler operations. My name is Afolabi Davidson of Energy Training Center. And I have my colleagues here with me, Adeshina Banire, there's Emeka Obeke, Ken Nweke. We are all working behind the scenes to coordinate this masterclass and make this a wonderful experience for all of our participants, who, as I've been told, are very experienced in the field of manufacturing. But first, before we go ahead, let's go over a few housekeeping rules. To ask the facilitators a question, you can type your question by using the Q&A button that's available to you at the bottom of your screen. And we'll ask that all microphones are to be muted and video shut down so we can have fewer technology disruptions relating to bandwidth. The facilitators will be able to view and see the facilitators as they speak. And as you know, technology relating to internet service providers can be a challenge sometimes because we have people on this masterclass from different parts of the country and from different parts of the world, actually. So if we have any issues relating to internet access, we will work to minimize them first and then correct them as quickly as possible. We ask you please bear with us. Questions will be treated after each presenter is done for approximately 5 minutes after each presenter. So without much further ado, let me introduce our first facilitator who's be speaking on boilers, types, inspection, and operators' responsibilities rather. And his name is Yemi Shoyele. Yemi Shoyele studied marine engineering at the State University of New York in the US. He has over 26 years of experience from Nigeria Breweries PLC, Starmac Limited, and Cadbury Nigeria PLC, where he rose to the position of chief engineer and then to manufacturing controller. He is the founder of First Setup Nigeria Limited, which is an engineering consulting outfit carrying out maintenance for many manufacturing facilities in Nigeria. He has also trained for many companies in the area of operations boilers, mechanical and electromechanical programs, as well as engineering, supervisory, and management courses. So I will be handing over to Engineer Yemi Shoyele, whose voice you will be hearing after mine. Thank you. Engineer Shoyele, you can go ahead.
Good morning, all. This morning I'll be talking on boilers, types, inspections, and operators' responsibilities for safety. First, we'll look at the scope of discussion, and we'll look at boiler types, boiler systems, safety precautions in boiler operations, inspection procedure, key preventive maintenance issues, and operators' responsibility for boiler safety. Now, boilers will generally classify into two basic types. And what are they? The first one is a fire tube boiler, which most of us, especially in the manufacturing industries, are very conversant with. Now, the fire tube boilers, as you all know, it's a shell and tube type of boiler with fire or smoke in the tubes and water in the shell. And the picture that you're seeing shows exactly what happens. This is a 3-pass boiler. That is, the flame is established in the furnace, which is considered to be the first pass. And then the hot gases make 2 different passes. The first one is a reversal after the back plate to the left. And the third pass is on the way out towards the right. And then it goes, the exhaust gas goes out of the stack. Okay, this is fairly common in manufacturing industries. Okay. Now, this is a sketch of water tube boilers. And as you see, it's a different concept entirely. In this case, you have water in the tubes and fire outside the tubes, okay? Whereas the fire tube boiler is fire in the tubes and water in the shell. Okay. Now, these are 2 basic differences. Now, let's delve in more and look at each one of them in a little bit more detail. What are the advantages of fire tube boilers? Now, they are relatively inexpensive. I'm sure you all know that. Easy to clean. You can see from the picture that it is easier to clean without necessarily having to go inside the boiler, except maybe on an annual basis when you go and clean the water side. It's compact in size, and that's why it's very friendly with manufacturing. I mean, most manufacturers would like to have something that's compact enough to be accommodated in the factory floor. Okay. Now, it's available in sizes from 1 to about 20 tons per hour. As you will see, it's limited in terms of capacity when compared to the water tube boilers. Now, it's easy to replace tubes. If you ever have a tube failure, and we do have this once in a while in manufacturing, it's easy to replace the tubes without necessarily having to go inside the boiler. Now, it's well suited for space heating and industrial process applications. Okay, next. Disadvantages of fire tube boilers. Like I said before, it is limited in terms of capacity as well as pressure. Now, it is not suitable for high pressure applications above 17.24 bar. Okay, so if you want a boiler that can give you 30 bar, 40 bar, 50 bar, you have to look in the range of the water tube boilers. Again, also limitation for high capacity steam. Okay. Now, this is just an animation of what fire tube boilers look like. You see the fires glowing, the one at the bottom, that's the furnace. So the flame is established in the furnace and the hot gases pass. At the back plate, there's a reverser to the left, and then on the topmost plate to the right, and then it's exhausted. I think that's fairly simple. Now, what are the advantages of water tube boilers? Water tube boilers are available in sizes far greater than, far greater than the water tube design, the fire tube design, up to several million pounds per hour steam, and are able to handle higher pressures up to 345 bar. Okay. Now, in terms of steam production, water tube boilers recover faster than their fire tube cousins. For example, if you have a sudden demand of steam as a result of increase in load, or indeed, if there is a sudden drop in pressure as a result of a leakage or whatever, a big magnitude leakage, the water tube boiler will recover very fast because the tubes are in, the water is in the tubes, and the tubes are relatively small compared to the fireplace. So the water gets heated up very quickly, as against the fire tube where the water is sitting down massively inside the shell. So it's easier to heat up and boil off faster the little quantity of water in the various tubes than to try to heat up water in the big shell of the fire tube boiler. Okay. And also, water tube boilers have the ability to reach very high temperatures. Now, what are the disadvantages of water tube boilers? High initial capital cost. Well, we say it's a disadvantage, but honestly, if you need a water tube boiler, you got to go for water tube boiler. Now, cleaning is more difficult due to the design. If you need to clean water tube boilers, in most cases you have to. In fact, in all cases you have to go inside. Okay, we'll talk about issues on going inside the boiler or the safety precautions in the coming slides. Okay. Now, another disadvantage about the water tube boiler is that there is no commonality between tubes. In water tube boilers, most of the tubes are similar, except maybe for about, in a 10-ton boiler, you might not have more than about 4-6 tubes that are different. The rest of the tubes are the same, and you could have up to about 400-500 tubes. And so in a fire tube boiler, you have about 500 or 600 tubes, and only 5 or 6 are different. So 460 something, or 80 something tubes are the same. So in a fire tube boiler, this is a disadvantage because the tubes are made and measured to size. Okay. Now, physical size also may be an issue. Water tube boilers are usually bigger than fire tube boilers, although there are some small packaged fire tube boilers, but relatively, ton for ton, they are usually bigger in size. Now, this is an animation of water tube boilers. Okay. Now, what you will see is at the top you have a drum, which we call the steam drum. Of course, at the bottom also there is what we call a mud drum or water drum. If you remember the slides, the first few slides I showed, indicating the water tube boilers, you will see that there is a lower drum called the mud drum. Okay. The flame is generated in the furnace. Okay. The entire boiler assembly is built and encased in a refractory wall made of special brick. Okay, so that there is no way for the heat to escape, unless of course there has been a damage. So as the fire is going, the fire is hitting the tubes, and to your left, you will see the water that's going up into the steam drum, and to your right-hand side, you will see the water that is flowing down into the mud drum. Okay. Oh, I did now. Screen is shared. Okay. Now, let us talk more about the boiler systems. As you know, we just refer to a boiler as a piece of equipment, but there are systems that make the boiler work as a unit. Now, this includes feed water systems, the fuel system, condensing system, superheater, forced draft fan, the economizer. Now, I'll just show you the flow chart, as it were, of the water system. Now we have, in the water system, we have the open feed water system, and then we have a closed water system, closed feed water system. Now, in the open feed water system, when steam leaves the boiler, it goes through into the services, to the load centers. That's where steam is required. And then, of course, after doing the work, the steam condenses and is saved in a condenser, and then it goes into a hot well, the hot well tank, and then into the feed water tank. Now, from the feed water tank, you don't see my screen? Excuse me, just.
Engineer Shirley, do you need some assistance?
Excuse me?
Do you need some assistance?
Yes, Ken. Emeka, please come. Sorry.
Share your screen.
Yeah, it says you are screen sharing. You are screen sharing already. What's up?
Yes, you are sharing your screen. We are following you. We are following you as you're sharing your screen.
Okay.
We're seeing your screen.
Thank you.
You can go ahead.
You can see it now.
Yeah, so thank you. Now, I was just discussing the open feed water system. After the steam leaves the boiler, it goes to the various places where steam is required. When the steam is utilized, it condenses, it goes first into a hot well and the feed filter tank. There's a filter, and then it goes into a feed tank. Okay, it's stored in the feed tank. Now, it's then taken by a pump, the feed water pump, okay, and circulated back into the boiler for boiling up. Now, there is also an auxiliary feed pump that is on standby. Usually, for boiler systems, you are supposed to have, it's by law, by regulation, you have to have at least main 2 feed pumps, main and auxiliary. In marine systems, it could be 3, because out there you do not have, you don't have the luxury of time, and when you're in trouble, you just need to get going. So it could be 3, but minimum is 2 by law. Okay. Hey, screen is hanging. Slightly changing. Sorry.
Okay, the screen is hanging, it's not moving.
Yeah.
Emeka, can you help resolve the issue with Engineer Shirley, please, to move his screen? Can you try using your arrows to go up and down?
Yeah, I did. It's not going. It's okay now?
Is that it?
Yeah, it's the next one. Okay.
Okay. Now your screen is moving now.
Yeah. Okay. off again. Start video. I need to go back to explain the closed feed system. I need to go back up.
So leave it.
No.
Right?
Go ahead. Yes, yeah, I want to go to the next one.
The next one after this.
Let's not start it. Yeah.
This.
Sharing screen. Are you sharing screen already?
This.
Not yet.
Yes, we can see your screen.
Okay.
I hope everyone can see Engineer
Yes,
Shirley's
sorry
screen.
about that. Just a small hitch. Now,
A few of our participants had sent the message that they couldn't see your screen. That's why I was asking.
sorry about
I
that.
hope they can see. I hope they can see it
Now,
now.
the boiler fuel oil system, again, you have the boiler, okay? The boiler fuel system consists essentially of the tanks, 2 settling tanks, as you can see at the top. It goes through a filter, okay? You must check you must go through a filter, whether you're using diesel or using light oil or heavy oil, you need to, because it's always debris. And then you also, you go to a pump, 2 pumps. Ideally, you have to have 2 pumps by law. Now, if you're using heavy oil, anything other than diesel, you have to go through heater. And again, by law, and also should I say by common sense, you will have to have 2 heaters, so that if you're having problems with one heater or doing maintenance on one heater, you don't have to shut down the boilers. So after the heaters, you go through another fine filter, okay? Because there are some, especially if you're in the bunker C region, if you're using bunker C oil, very heavy fuel oil, after heating, you will discover that you still have some fine sediments that has to be removed. Okay. Then from the fine filter, you go into viscosity, what we call viscosity regulator, okay, and then to the burners. Now there is also a provision for starting with diesel. All boilers that that use oil will have to start with diesel before you can switch to heavy oil. This thing is still hanging in. Okay, now let's look at condensate recovery. Like I said, this is another system in the part of the boiler system. Now, you need to recover your condensate for obvious reasons, because that's a lot of energy there. Okay. Now, when your steam boiler generates steam, sends steam out to the various consumers, 1, 2, and N. After utilization of steam condenses because you have steam traps installed all over the place, and then it's collected in a condensate, what you call a condensate reservoir. Okay. Now, this condensates, the condensate reservoir holds all the condensate that returns from all the consumers, and it's eventually pumped back. Now, this time through what you call a degasser or deaerating feed heater. Okay. What this does essentially is to remove oxygen, because you need to always ensure that your boiler feed water is devoid of oxygen. Now, as we all know, oxygen will lead to very fast corrosion. Okay, and then from the degasser, okay, it goes back into the boiler as feed water. Okay, now one of the things that make the degasser work the way it is, there are various types, but the commonest type is this one, that you have a low steam pressure from the boiler into the degasser. You have a perforated pipe inside the degasser that bubbles through the degasser And as it bubbles through, it ejects whatever oxygen that is, or other gases that are inside the water. Okay. Now, the economizer is another part of the boiler, it's another system. It is a heat exchanger basically through which heat water is pumped. Now, so the feed water arrives at the boiler at a higher temperature than it would have been if no economizer was fitted. And then less energy is required to raise steam. Okay. Now, you can also have the gas economizers on shell boilers, as you can have also on the water tube boilers. Now, this is a shell boiler with an economizer. Okay. You can see the economizer installed at the exhaust pipe of the chimney. That is to make sure that we can use the usable exhaust gas temperature. Okay, but care must be taken such that you do not bring down the temperature of the chimney, of the gas leaving the chimney, too low that will cause corrosion, because a lot of the oils we use have sulfur, and sulfur, when burned, becomes sulfur dioxide, and moisture with sulfur dioxide is sulfuric acid. So by design, I mean, this is nothing anybody can do about it. The operator or the user cannot do anything about it. It's already designed such a way that you will not fall below a certain temperature. Okay. Now, one thing we need to know about the economizer is that it is to our advantage if it's installed, because once you fire your boiler, you will always have exhaust gas that still has some energy in it. For example, it is typical that when you have an economizer, a 10-degree rise in feed water temperature will give you an improvement of at least 2% in energy efficiency. Now, this is a typical economizer bundle. This is exactly what they look like when you see them on boilers. Just a bunch of tubes mounted on the passage of the exhaust flue gas. Now, one of the things you need to note about the economizer, again, is that one of the advantages is that because it's in the it's on the high pressure side of the feed pump, you can always get water temperatures in excess of 100 degrees C. Okay, but you also have to be sure that your boiler water level control is of the modulating type, not the on-off type. Otherwise, you have issues. You might run water in the economizer, you might run the economizer dry, that is without water. That also can destroy the economizer. Okay, so you need to have a modulating type of feed water level control. Okay. Now the heat exchanger should not be so large. That the heat exchanger, the economizer heat exchanger should not be so large, so that you do not cool down the flue gases below their dew point. Okay, which may result in corrosion and whatnot. Okay. And also, if it's too large, you may have, that is, if the coil is too big, you may also have the feed water boiling the heat exchanger, which you don't want. You really don't want steam going into your feed pump. Of course, your feed pump will not handle steam anyway. Okay. The next thing we'll talk about is the superheater. As the name implies, it is a real super, because what that does, especially in power plant, for power plant requirements, power plant requires a steam turbine that is fed with superheated steam. Now, so if you look at the sketch of the water tube boiler, after your steam, how do I go back? Okay. Now, after the steam leaves, the saturated steam leaves the boiler, leaves the steam drum, it is then passed through a series of coils. Normally, when you look at it inside the water tube boiler, they look like pendants. It's just hanging, okay, on the passage of the heat, of the hot gases. So you just take saturated steam from the steam drum and then pass it through a set of tubes again, and it is superheated. And then this goes to the turbines. Now, this is a typical and real superheated steam, superheated tube bundles, which now again, the superheater also is not without some care. You will also need to be careful that you do not superheat, because the degree of the superheat needs to be controlled so that you do not cause any damage to the turbine blades and other accessories. So, and this is done automatically usually because there's a temperature control that's watching the superheated steam temperature. And if need be, water is injected again into the superheated steam if the degree of superheat is too much to bring it down. Okay? In fact, in some manufacturing industries where water tube boiler at high pressure is used, they also have this superheater because at the exhaust of the turbine, the exhaust steam from the turbine is still very high in most cases, and so they always have to superheat before they send it for heating and whatever for factory operations. Now let's look at the safety aspect of this business. Now this is a picture of a catastrophic failure of a boiler in one of the factories, not in Nigeria though, but you can see the whole boiler is a water tube boiler. The whole boiler crumbled. This is a boiler that's about 2-story building high, 2 or 3-story building high. The steam drum came down, and then you can imagine all the pipes are flattened on the floor. And I think also it may have also taken some people with it. Now there are precautions to be carried out at boiler commissioning. Hydraulic test needs to be carried out. Okay, hydraulic test is subjecting the drums, both mulch drum and steam drum, or any other pressure vessel to hydraulic test, and this is done with 1.5 or 1.5 times the normal operating pressure. Okay. Now, at the start of the boiler, before you commission the boiler, you've got to check if the feed pump outlets are open. Always ensure that before you even start at all, the feed pump outlets are open. Now, install an automatic ash system. Make sure that it's an automatic ash removal system. Remember that in fire tube boilers, particularly, you do not have the luxury of going in and out, okay, of the boiler, except you're doing a shutdown maintenance. So at certain intervals, you have to have the ash in the furnace removed. Then also, you need to check all electrical connections. Make sure that you check all loose and wrong connections, and make sure you rectify any connection before starting your boiler. But more importantly, to operate a boiler, any boiler, you must have a trained and technical operator. You have to hire a trained and technical operator, not a modern school or secondary school, basic secondary school graduate. No, you have to have a technical. Okay. Now, part of the precautions required to be carried out regularly also include never operate boiler above the design pressure and above design pressure, and check for the safe operation of the safety valves as well as the fusible plugs. Safety relief valves in particular have to be tested depending on the regulations where you operate or the company policy. If you are doing for using water fire tube boilers, it's not too cumbersome. You can do this once a month or once in 3 months. It's important you ensure that the safety valves also are working, the relief valves are working very well. Okay. Clean the water pump strainer to avoid starving the pump of water, and ensure that only treated water is fed into the boiler. Okay. Carry out water treatment as advised by the laboratory. This is very important, okay? So you don't have problems down the line. And now carry out maintenance of burner assembly and fans according to manufacturer's recommendation. Okay. Now, boilers inspections. Boilers are typically subject to routine inspections annually, although more frequent inspection may be necessary for the performance. Sorry, may be necessary. Move this up a little bit. 1 moment. If performance malfunctions are identified for older systems or in certain areas based on state or local regulations, that is, you need to carry out continuous inspections of your boilers when they're in operation, and then plan for rectification at the most appropriate time, unless it is it has a safety implication. When that's the case, you have to shut down the boiler and carry out your rectification. You don't wait for any time if it's safety related. So regular boiler inspections are imperative for minimizing downtime due to unexpected malfunctions and ensuring that boilers are in good working order. Okay. Now, you've also got to prepare your boiler for inspections at the end of the year. There is a mandatory insurance inspection that you must carry out annually on your boilers. And I hope everybody is adhering strictly to that. Not just because of the value of the boiler, but because of the consequences of a boiler failure, like boiler explosion. Okay, so now an inspector comes in, or you will invite the inspector to come in once a year through your insurance company. So that these are things that you need to do before the inspector arrives. You drain the water and wash the boiler thoroughly. Okay, remove the manhole and handhole plates, wash out plugs and inspection plugs in the water column connections. Cool down and clean the furnace and combustion chamber. Remove the grates from internally fired boilers. Remove brickwork insulation, especially on the water tube boilers, to determine the condition of the boiler headers, furnace support, and other parts. Make preparations to provide proper access control. Remember, for a water tube boiler, you have to go inside. Now, expose, and then for also control and exposure to asbestos fibers during inspection. Now, gradually, if not everywhere, fiberglass has replaced asbestos fibers. As you know, asbestos is not very friendly. Okay. Remove the pressure gauge. Prevent steam or hot water leakage into the boiler by disconnecting the pipe or valves at the convenient point or through any other means approved by the inspectors. Close, tag, and padlock non-return and steam stop valves. It is important that when you close these valves, you tag them, put the padlock, okay? And you do that before even opening the manhole or the handle covers. Now, open the drain valves and or drain cocks between two valves. Close, tag, padlock, blow-off valves need to be closed, tagged, and padlocked, okay, after draining the boilers. Right? Disconnect the blow-off lines between pressure pads and valves when possible. Open all drain and vent lines. Then, prepare for the hydrostatic pressure, which I said should not be more than 1.5 times or 1.5 times the maximum allowable working pressure, okay? Or in accordance with other limits set by your local or state regulations, okay? The test should be controlled to ensure that the required test pressure is never exceeded by more than 2%. Now, again, the water that is used for hydro test pressure cannot be too cold, it must be warm, but usually between 70 to 120 degrees centigrade. Okay. Now, let's look at the equipment required for high pressure boiler inspections. That is, before you go into the boiler, you need certain things. Now, first of all, anything that is small enough to fall down in the boiler tube should be removed prior to entering the boiler. That includes wristwatches, ear rings, hand rings, and other items. Okay. Now, the recommended equipment for performing high pressure boiler inspections include: 1, the safety hat, the safety glass. You must have that. Safety shoes, your gloves, coveralls, and your flashlight. These are things that you must have with you, or you must have on you before you go into the boiler. Camera, with a securely closed battery compartment. In fact, you have to use what we call cameras, intrinsic cameras, so cameras that cannot cause sparks or anything. Inspection mirror, magnet, and a little container which you sling over your shoulder for storing deposits. So when you have some deposits in the class, be it scales or suit, you have to evacuate them. A knife, a screwdriver, or other scraping device. Now, very importantly, any necessary atmospheric testing equipment before you ever venture into a boiler to work, or for anybody to go and work, you need to have the atmosphere tested, just in case you might have some dangerous gases still not properly vented. Carbon monoxide is a typical example, and it's not uncommon to have such issues so that people don't go in there and faint. Okay, and then any additional advanced testing equipment that you may have. Okay. Now the precautions as this. Apart from having appropriate safety gear mentioned above, inspectors as well as owners and users preparing for boiler inspection should follow all planned safety procedures. That is, whatever procedure that the company has laid down for safety should be strictly followed. Now, other safety recommendations include: one, this is, in fact, for me, this is the most important when you're preparing for inspection. Inspect with a partner or have an inspection attendant. Now, please never go inside the boiler unless you are two. Now, in the case of water or fire tube boilers, where you can only accommodate one person, especially on the water side, have an attendant or a partner standing outside the boiler with a hammer, and when he says one gives a one tap, he wants to find out how you are, and you inside the boiler will have to reply him with 2 taps so that he knows that you are alive, please. And for especially again for fire tube boilers, you should have something like a safety harness. We used to call it in those days monkey ropes, tied to the guy who is in the water side of the boiler. You remember that on the water side of the boiler, you cannot stand, on the fire tube boiler, you cannot stand anywhere. You can only crawl on the water side at the bottom. And you need to do this for the annual inspection on the water side. On the fire side, you can stand inside the furnace or almost anywhere. So, but then you need to ensure that where necessary or where possible, get 2 people to go in, or get a second person, an attendant or partner, standing outside. Okay. Now, request for other boilers to be shut down, or not to be, especially if you have so many boilers in series, you will have to ensure that other boilers are not blown. That is bottom blowing of the boiler during your inspection, because the noise from blow down can cause a distraction for the guy who is inspecting the boiler. Okay. Ensure that all valves are turned off and locked out prior to inspection, including fuel blow down, steam, chemical feed, and water valves. Now, this is a typical blow down, automatic blow down arrangement. Okay, you have your boilers. This is a water tube, fire tube boiler, and you have your boiler. You have the automatic blow down connected to a vessel, a standalone vessel, so that you, by the time you blow down the boiler, remove all the rubbish, it goes into the blow down vessel. Your noise is reduced. The heat, excessive heat also from the water will be reduced as well. Okay, those are the basic things that check temperature of the diameter to ensure. Now let's quickly move to maintenance issues. Now there are some key maintenance issues, things you need to do weekly, daily, weekly, monthly. Well, let's start with the monthly one. You need to clean the nozzles for the atomizer, especially when you're using oil, okay? And the nozzles and spinning cup, if you have a rotary cup type of burner, okay? Regularly. Now your fire eye sensor and the chimney smoke sensors need to be cleaned. Your combustion chamber needs to be checked at least monthly for any oil residue. Now, in 6 months, clean your burner again and burner assemblies. Now, clean your tubes at least once a year. It's very important. For boiler tube, for the fire tube boilers, because you have your water outside, inside the shell, you must do a chemical cleaning of the boiler once a year. Same as the water tube boilers. You must also do the chemical cleaning of the inside of the tubes once a year, so that you do not have a problem with heat transfer. Okay.
Engineer Shirley.
The boiler.
Hello, Engineer Shirley.
Yes, please.
Sorry for interrupting you. I wanted to let you know that you need to wrap up very quickly, because we have 2 other presenters.
Okay.
And you have some questions to attend to. We have a couple of polls that we need to do.
Okay.
So that we'll have enough time, and the participants will get the benefit of listening to the other 2 presenters who are also very critical presentation.
I'll just leave a few slides out and go straight to the operator's responsibility. There are key issues there.
Okay.
Now, this is just a picture of what happens, again, when you do not do your water treatment very well. You have limescale formation. This is an extreme case of tube fouling, which can lead to early failure of tubes. This is a water tube boiler. Okay. Now, operator's responsibilities. I'll just pick the very key ones. Okay. Now, ensure that boiler is operated at normal operating water levels at all times. Now, do not add water to a hot boiler when the water level cannot be immediately determined. Okay. Operate the boiler with in accordance with SOP, operating procedure. Carry out boiler pressure tests, and we have said that before. Maintain proper steam pressure or water temperature. Now, at least once a day, carry out low water fuel cutoff and feed for water pump controls. Now, this particular one is very key for me. The life of your boiler actually rests on this. If you don't do it, it's a recipe for chaos. Despite all the electrical, electronics, safety devices, this is a true test that when you get into a low water level situation and your boiler feed pump is not delivering, the burner will cut off and the boiler will shut down on alarm. Okay. Other things are so let's see. Now, again, the last thing I want to mention is please maintain truly a true boiler room log, recording all appropriate data and documenting. This is the important thing. Documenting any unusual conditions for necessary engineering intervention. Thank you very much for listening. This is
okay.
How much
Engineer Shirley, thank you. Of our participants have been asking if they will be able to receive your slides. That would be the first question you need to answer. Although I've told them yes, but I need you to reiterate that the slides will be made available to our participants.
Okay.
Okay, we have a couple of other questions here. So the first question, what are the causes of slow pressure buildup or loss of pressure?
Okay. One of the main causes of slow pressure buildup will be if, let us assume that your firing rate is okay and you put in enough energy in the flow rate of the gas or the oil is okay. One thing that normally prevents you from firing up, and I've seen this in industries, is low feed water temperature. You must not, let me say it right away, the fire tube boilers that we use in most of the manufacturing industries, we have this kind of problems a lot. You must ensure that you have, as close as possible, I will say, look between 92 and 95 degrees C minimum as your feed water temperature. If you do that, you will not suffer slow buildup, and you have steam drop because your consumer, the guy who's using the steam, the consumer, the factory is running, and so whether you like it or not, if you are unable to meet up, then you will continue to drop. Okay, the first thing is you must have an adequate feed water temperature. I recommend between 92 and 95 degrees centigrade for the water tube boilers. That is the main thing. But you must also ensure that your firing rate, the adjustment of your burners is okay. Nobody has done anything after a weekend maintenance or whatever. Somebody did not adjust something very well. Ensure that is okay. Once that is okay, make sure that you have your feed water temperature as close as possible to 95. Then there will be no problem.
All right, thank you. That question was from Anton Roos, by the way. We have a question from Isaac Ackman. Says, what is the required limit of dissolved oxygen of the feed water from the degasser entering the steam boiler?
Well, I don't have the figures here, but it's probably not 10 ppm or below 10 ppm, something like that. But there is recommended boiler operations maintenance. Again, even your boiler manual manufacturer will have specified that. But I think it's in the range of something like about 10 or 12 ppm. It's as low as that, very low. If it's possible to get it to 0, then you should do. But I know there will always be. But the question is, why would you have a high dissolved oxygen in your feed water? It's because your degasser is either you don't have a degasser installed. I have seen some funny looking factories. And where they are installed, it's not working very well. The one I showed in my presentation is a type that has a perforated tube inside the degasser at the bottom, through which low pressure steam is passed, and this forms a bubble continuously. And when that happens, you are able to exhaust almost all the dissolved oxygen. I don't have the right figures now, but I think about a very small ppm.
Okay. This other question is another one of our participants. It says, how can some fire tube boilers treat condensate return water if it's not installed with the degasser?
How can
some fire tube boilers treat condensate return water if it is not installed with a degasser?
If you don't have a degasser, you just need a degasser. Because that's a simple truth. You need something to agitate the condensate or whatever. You need some physical agitation, either by gas or whatever. You just need it. If you don't, then you'll be having too much high oxygen, and then of course your pipes will be corroding very, very quickly, on the water side of the boiler as well.
Okay.
You just need it. You just have to have a degasser.
Okay, great. So we'll stop questions there for now. All of the other questions, because you have quite a few of them, we'll attend to them as the masterclass goes on. And if we're not able to get to them, we will get to them afterwards. For now, we would like to take a poll question. My colleague Emeka will be handling. Emeka, are you ready for the poll question?
Yes, I'm ready, sir.
Okay, so can you show the poll question, the first poll question, please? Okay, the question is, what is the main challenge presently encountered in your boiler plant? And you have several options there. Feed water temperature control, boiler pressure fluctuations, flame failure at starting, steam system, either controls or others. Please take just a few seconds to answer this question. What is the main challenge present encountered in your boiler plant? Very quickly. So you can just select one or two of the options and then submit your answer while Emeka keeps track of the responses. Emeka, how are we doing in terms of responses so far?
So it's still ongoing. We have 26% responding so far. Still ongoing, sir.
Okay. Let's do this very quickly. So what do we have now? Emeka.
Ended the poll. I'm sharing the results right now, so you see.
Okay. Here are the results. 13% says it's feed water temperature control. We have 27% saying it's boiler pressure fluctuations. And the most responses came on the flame failure at starting, that's 29%. We have a few of the other ones at 9, 10, and 12%. Thank you very much for those responses. We'll take a couple of more polls during the other presentation. I'd like to invite my colleague Adeshina to say something real quick. Adeshina, are you prepared? Are you ready?
I'm ready. I'm ready.
Okay, go ahead and share what you need to share.
All right. I want to say a very good morning to all our participants this morning. Thank you for joining us. I want to share with us our upcoming boiler virtual modules that I believe is going to answer most of the concerns and the questions that we have brought up this morning. I want to make out to project the Excel schedule that is showing the course titles, the dates, and the duration. According to the Federal Republic of Nigeria Official Gazette and Factories Act Cap F1 laws of the Federation for Boiler and Pressure Vessel Regulations, we have come to understand that in Section 10, there are set guidelines for operations of industrial boilers and pressured vessels. And I'm sure most of us are conversant with the guidelines. These guidelines covers registration of factories and industries for one, licenses to install boilers, own boilers, and to operate. And the guidelines also covers inspection, just like we have with some of the insurance companies. You know, what they do is they come, they inspect, they have the licenses to deploy inspection to all of our industries. And thirdly, the guidelines also covers training, certification, and recertification for boiler operators and maintenance personnel. Now, we agree that for every industry, two key things that are very important to every boiler plant is safety and efficiency. You can't take that away from all boiler systems. Every boiler training and certification issued to boiler personnel by ETC, which is what you have been looking at, is in pursuant to this regulation by the Federal Republic of Nigeria, and is valid, is going to be valid anywhere in the world. Because one of the things that Energy Training Center is doing is not just to take you through boiler training programs, but to give you an accredited certification. So we are here because we have discovered a gap, and this gap is what we are here to fill, both for those who are playing in the power industries, that's for the power boilers, or those who are playing in the manufacturing industries and the pharmaceutical and other industries using boiler. ETC, being a training center of sorts, will be deploying these 10 modules that you are looking at as technical training programs virtually. And they are all going to be aided by simulations and project work assessments. So the modules will be deployed virtually, and all participants are going to be eligible for some benefits. And this is the part I need you to really be attentive to. What differentiates us from all other training vendors with respect to boiler training programs is that all our paid boiler modules qualifies you as a participant, if you attend our training programs, to be a member of an international professional energy body from the United Kingdom called the Energy Institute. Now, they call them EI. EI is an international chartered professional body specifically devoted to efficiency, safety, development, support for individuals and organizations. They work in the energy space to ensure that people maintain safety and international best practices, as well as those who are using energy generated or related equipment, e.g. boilers. So if you enroll for any of our courses, that you are part of the participants for any of these courses, apart from our certificates of attendance or proficiency, one of the things you are going to gain is automatic membership to this international chartered professional body. That is one. Secondly, we'd like you to know that these training programs are going to run with certain customized simulations and animations. It has a specific class size. It's not going to be a larger class size as we have now. And so it's a matter of first come, first serve. For example, the next module, the first module that is coming up, it's boiler safety, standard operating practices, and legal requirements, June 10th to 11th. Now, what we expect is those who register early to get the adequate number, class size that we need are those that will attend this module. The rest that will come later will wait for next batch. The reason is we want to make the classes as interactive as possible. We can't allow people to speak in this forum because this is just like a testing of water. This is like a dive into the intro of the boiler system. We can't go into details here. We can't discuss all your challenges here. We can't address all the questions that you are raising here. But if you attend these training programs, you will be able to interact with our experts because we're going to be having experts coming to take each of these modules from the US, from Canada, from the UK as well. So each module is going to have different experts in that subject matter that you will have opportunity to interact with. Number 3 benefit is that our certificates are going to be co-endorsed by ETC, that's we, Energy Training Center, as well as the Energy Institute in UK. So lastly, one of the things I want us to know is that all of these modules have been put together to match up with the international content required for the certification and accreditation that is given by the UK body called the Boiler Operations Accredited Scheme. They call it BOAS. So the contents are in sequence. All of these are put in place in case you are interested in getting specifically accredited as a boiler operator or boiler engineer. So this is optional. Apart from all the benefits I've put forward, if you have any boiler certificates yet, but you want to be a certified and accredited boiler personnel, you need to go through the 10 modules that we have here. If you go through these 10 modules, at the end of the 10th module, you will discover that we have each of these modules to cover all the system parts incorporated in a boiler plant. This will now qualify you for the assessment examination for BOAS. And upon finishing the 10th module, we would be able to register you for the assessment. So the registration and assessment fee for those who are interested in becoming an accredited and certified boiler operator and engineer is £475. That is just for the registration and assessment and the exam fee and the accreditation put together. But these 10 modules are already packed together to prepare you for that accreditation. So if you do not want to get accredited, but you want to be part or a member of the professional body that I've spoken about, the EI, all you need to do is just to attend one of the modules, any one that is relevant to your current challenge, okay? You can attend it and we can assure you that you will get value for whatever you are coming for. So I think that's all I have for now. Thank you very much. If you have need for further inquiries, you can contact us. Our contacts should be displayed. Emeka, and our emails and phone numbers are there for you to meet us. And our training programs are customized for certain industries. So you could say, okay, you want us to come and run it for all your boiler operators and prepare them. Okay, thank you for the contacts, okay? That's our email there. You can send us an email and would definitely attend to you. Thank you very much. We can go to the next facilitator now. Thank you.
Thank you, Additional, for that important information. We will now go on to our next facilitator. Let me just give you a brief introduction of our facilitator. Dr. Pranjal Kumar Pukan is a PhD. He has a PhD degree, and he's an accomplished, internationally acclaimed professional in manufacturing processes and operations management. He has lots of noteworthy experiences and achievements in the field of boiler operations, maintenance, and troubleshooting. Dr. Pranjal has used various tools to save plant downtime with respect to boilers, power plants, and airborne extruder gear assembly up to 150,000 kg weight. He has a total of 23 years experience in the manufacturing processes and operations, as well as project experience from installations to commissioning of several manufacturing plants. Dr. Pranjal is a fellow of many reputable professional bodies, IEEE, ISME, IIPE, and CEng. And Dr. Pranjal is joining us from India today. And interestingly, today is Dr. Pranjal's birthday. Dr. Pranjal, I wish you a very happy birthday. And you may go ahead and start your presentation, Dr. Pranjal.
Yeah, thank you very much. Am I audible to all of you?
Yeah, we can hear you, but you might need to increase your volume.
Okay, volume is high.
Oh, it is? Okay.
Now it's okay?
Well, for me, I don't know if all of our participants, I can hear you, but the volume is actually quite low, but let's see how it goes. Start your presentation. And yeah, there you go. We can see you now.
Okay. So can I share the screen now?
Yes, you can share your screen.
It's shown as host disable participant screen sharing.
Okay, Emeka, can you please give Dr. Pranjal the access to share his screen?
Yeah, done, sir.
Okay. Yeah.
All right.
Good morning to all of you. Yeah, good morning to all of you. I am Dr. Pranjal Kumar Phukan from India. And today I will take you to very basic things of like what are the modern technologies which we are using in boiler operations globally. So my slides are based on 5 chapters only. Like first is about the brief about boiler process. Second is like how we can use IoT, Internet of Things for monitoring. And third one is how can you use SCADA for boiler operations control. Fourth one is machine learning. And last one will be the cogeneration systems, which will go through very basic things so that you can understand for the future detailed courses, which already Mr. Adrishna has given the timetables for your processing. So first I'll go to the boiler process descriptions. You must be knowing that any boiler consists of these important sections, which you already heard in the first slides of Engineer Aisha, that economizer, boiler, superheater, desuperheater, reheater, steam distribution header, condenser, and finally the cooling tower. You can see the slide is that just the flow diagram, how the things are being positioned in a particular boiler operations. May it be like water heater, or it will like the gas fired, or water fire, what means water heaters, or you can say air heater, something like. So this is the basic plant layout where they are positioned, like how it goes to the particular steam distribution system, so that we can run the turbine. So in the boiler description, what I want to say is that steam boilers are very important equipments. You must be knowing that any power plants, and you must be also knowing that any tripping of the boiler will lead to the entire plant shutdown. So it's a very important thing that you have to maintain the performance, and also the safety of the plant, safety of the boiler, and safety of the people, means what means the employees, so that this anything should not happen to make it impossible to rectify. Based on that, I want to say that one thing we have, like in artificial neural network application, we can use for steam boiler trips, which have been developed, designed, and parameterized. Here, I will not touch artificial neural network this time. Instead of it, I will go for the SCADA system, where we can control boilers at remote location through means located geographically at different locations of the particular demographic area, so that in which location human beings cannot go or cannot attend the problems, so which we can attend the problems remotely. And third one is the increasing complexity of the thermal power plants boiler operations day by day because of the development in technologies and engineering. Now, in second slide, in this slide, you will see what I want to say is the water is the most important part of any generation of steam, and inlet water to the steam drums should be purified form, for which pH value of the water should be maintained, and this can be controlled remotely or through the latest technologies like switching on and off of the feed water pump. And you must be knowing that failure of any of the one pipe does not affect the boiler operations. However, the water is passed through the economizer, thus the heat in the outgoing gas is recovered. So in that way, the heated water is made to flow through steam and water drum. Now, what are the critical control parameters? The critical control parameters which I have shown here in the slide is: number one is level control. Second is pressure control. In level control, you are seeing steam drum level, deaerator level, and hot oil level we have to control. In pressure control, we can control forced draft pressures, induced draft pressures, steam drum pressures, deaerator pressures, turbine inlet steam pressures, and balanced draft pressures. In flow control, air flow, steam flow, water flow. So why I'm showing this? Because these are the critical parameters which needs to be taken into account while we are using the modern technologies like IoT or SCADA or DCS or machine learning, whichever, or artificial intelligence, whichever, but these are the parameters which you need to take into account while controlling the parameters. Now, before going to my slides on modern technologies, you must be knowing what is the history of control and automation of any equipments in any industry, including boilers. The first was a PLC, program logic controller. Then we see that with the advent of electrical control at logic gates, then further advent was with logic gates and manual control. So if we go by, actually this is in a descending order. The first one is a manual control from the bottom, and later it went to PLC. And now instead of PLC, we are using what? DCS, distributed control systems. The drawback of the manual control was that human errors were there, hardwired logic controls were there. In this, contracted relay together with timers and counters were used in achieving desired level of automation, and bulky and complex wiring was there, which was involving a lot of rework to implement any changes in the control logic, and the work can be started only when the text is fully defined. So these are the drawbacks of the conventional systems. They're prone to errors of humans, and in the coding process of this implementation microcontroller, it requires a fast and efficient processing, which on the other part depends on the length and subroutines of the coding process. So further to that, if we go for the monitoring process, how we can monitor, it is very important because it is safety of workers and high secure operation of the plant is ensured. It is the boiler parameters we can monitor using wireless communications to avoid accidents, and boiler parameters are monitored by using sensors like temperature sensors, humidity sensors, water level sensors, gas sensors. These are monitored based on some of the parameterized factors. The first one is use of IoT, Internet of Things. In Internet of Things, what are the parameters? One is that monitoring of temperature is important to avoid the problem in power plant. Measurement of water vapor content is also monitored. Monitoring of the boiler tank level, which is important because it avoids or lessens the increase of maintenance cost. And if the water level increases beyond the limits, the turbine will get damaged, you must be knowing, due to overflow water. So the water level monitoring is also part of the boiler monitoring process. Now, IoT enables plant operators and managers to monitor their boiler operations through a host of plant sensors and cloud-based analytics, offering operational support and real-time troubleshooting services. So why we are using this modern technology? Because they're helping in two ways. One is real-time monitoring. Second one is remote monitoring. So we don't need much of the people to move to the field or some of the remote places very difficult to access. So it is particularly helpful when routine boiler tuning is necessary to comply with the new flue gas emissions regulation, because you might be knowing that nowadays due to carbon footprinting that fuel gas emission is very much controlled, regulated globally. So this is also required to be maintained. Otherwise, the law of land or the particular country's regulations, international regulations won't allow to operate the power plant with emitting boilers, causing environmental problems. Now the method for IoT is, it is always dealing with the boiler drum level controlling system. It is very important thing you must understand. In IoT system, you always use the boiler drum level controlling system. It is controlled by Arduino Uni microcontroller. It is a type of microcontroller from the output of sensors. This particular microcontroller receives the pulse signal and sends to LCD or personal computers with the help of LAN. Another side, the same level signal is sent to IoT using Wi-Fi module through your handsets. So in the flow diagram, you can see the feed water supply is controlled is being sensed by three. One is temperature, level, and humidity, which is being as an input to the microcontroller, and output is to laptop, and other is output to relay and pump. Why relay and pump? The relay will get switch off, switch on, and based on that, it will trigger the functions to the pump for switching off or switching on in real time, based on the data available to this particular microcontroller. These sample illustrations I'm just showing, like what are the things which can be diagnosed based on these IoT functions using microprocessors. One is boiler mass energy balance, fouling diagnostics, fuel and emission diagnostics, leakage detections, then additive and power consumption and cost monitoring. Similarly, main display and process displays are there. Then quality and quantity of the bed diagnostics can happen. Online corrosion monitoring, reports, document management for the top management on their basis of daily, fortnightly MIS reports. Then also you can have the alarm message for operations. The significance of these three elements, what I have discussed with the boiler drum, is that the real-time monitoring is happening and controlling. So it is using DCS, one or three element method, which is because you must be knowing that boiler drum level control is critical for both thermal plant protection and equipment safety, and applies equally to both high and low level of water within the boiler drum. So results is very clear. It shows the current reading of the boiler drum parameters. If it automatically controls the three elements of the boiler drum. So results is the three element of the boiler drum, that is drum level, feed water flow, and stream flow, can be controlled in a better way. By using IoT instead of other communication control system, it has been easier to achieve higher speed of control with less space of RAM, and low power consumption. And due to this three-element control system, power generation and overall efficiency of any thermal power plant is increased. In future means way forward means already been there. Instead of three elements, now we have five elements which are being controlled with five parameters, which are temperature, pressure, level, humidity of feed water in the boiler drum, using the present current IoT technology. Because IoT is easier to monitor and control most of the parameters in boiler drum. In thermal power station, it is the most essential things, parameters, which needs to be controlled. If manually, then it's okay. If you want more advanced case, then obviously it should be through IoT. Now we are coming to second technology, that is SCADA. SCADA is supervisory control and data acquisition system. It is to automate any power plant in various locations of the demography and minimize human interventions. It is used to monitor the system PLC, program logic controller, for use of internal storage of instructions uh, for internal storage instruction for implementing functions like logic, sequencing, timing, counting, arithmetic to control through digital and analog output modules. उसको बोलो जाके ऊपर जाएगा मानस पर घूम क्यों रहा है? It stands for supervisory control and data acquisitions. It is used to monitor and control plant or equipment. The control may be automatic or initiated by operator commands. The data acquisition is accomplished firstly by the RTUs scanning the field inputs connected to the RTU. Now this RTU may also be called as PLC. Okay, it is usually at a fast rate. The central host will scan the PTUs, usually at slow rate. The data is processed to detect the alarm conditions, and if an alarm is present, it will display it on special alarm list. The method is all the values can be filled up by the introduction of the automation technique into the power plants. The automation technique involves the automatic control of all the processes, which includes the monitoring and inspection needs, provides for a very efficient system. The automation process helps the company having the power plant to reduce the amount of errors that occur, a reduction in the human resources, increasing efficiency, and most importantly, very cost effective. So, what I was saying, that at the beginning of the cycle of each CPU brings in all the field's input signal from the input signals from the module and store in an internal memory as process of input signal. This internal memory of CPU is called process input image, or you can say PII. Now this CPU takes the status of the input from PII and process all the rungs in the user program. The result of the user program can scan is stored in the internal memory of CPU. This internal memory is called process output image, or PIQ. At the end of the program, the CPU transfers the signal states in the process image output to the output module and further to the field control. So this is the working, like we run, okay, then read the PII reads it, execute the program, then send it to PIQ, and finally from PII to PIQ it is scanned, okay. It is being scanned by the for the SCADA database for graphical view of process monitoring for operator station in the central control room. Now, how do we interface? IO driver called as SCADA picks up data and transfer to the image to database, and this image is called driver image. This driver image is available in SCADA database, is used for graphical view of the process monitoring from operator stations in the central control room. Like how it is being shown here, how we are interfacing PLC, program logic controller, and SCADA system. So interfacing happening like SCADA and driver and PLC. See, the DD or OPC server is connected to driver, which is further connected to PLC. PLC is collecting data from the field like remote locations field on real-time basis, which is being fed to SCADA to control on 5 parameters, which I've discussed earlier on a real-time basis. So this flow start, how SCADA works. If you see the start is switch on feed water motor pump, then it maintained this much percentage of flow across the feed water valve. Then it again maintains 15% flow across feed water valve 2, then monitor the economizer and monitor and then if level is 50% below, then it is no. If it is more, then it's yes. Then it get adjusted and maintains the primary heater temperature, and finally monitor and maintain the secondary heater temperature. So based on this flow chart, you can either stop the process or you can continue the process. Now this is all the machine learning cases. If you see the machine learning cases, only thing is you are replacing the human knowledge experience with AI predicted module based on the big data. And based on that, we can simulate the data utilizing AI for optimum setting suggestions. So here you can see like there are 3 parameters being clubbed here. One is economic efficiency, operational performance, and environment performance. In environment performance, the properties of exhaust gas like NOx, CO, unburnt ash contents. In operational, control margins for operation terminals. And in economic efficiency like fuel consumption, auxiliary power, ammonia consumption, etc. These are the target values we need to monitor and control, okay, so that the performance and economy and operational efficiency is achieved. System integration, it is for the traditional process on the top of it. Only thing is we are using the cloud basis, cloud server, where OPC server, DT server are maintained. DT means digital twin server is maintained so that we can have the data on real-time basis being processed separately on the DT and OPC server, optic server, so that we can have a real-time analysis of the data analysis on the data achieved by the DCS from the field on a better, you can say better method or better process or more clarity on getting any report for taking action on real time. The effect is that if it is tuned by the experienced engineers, we can achieve the value of 70%. If it is tuned by DT and DT estimated, it is C. The NOx value is reduced to 65%. In the same way for the spray valve opening, if an experienced engineer is using, then 47% is the chance that it will get open, target control value. But if you use the DT, it is 48%. And if you see the duration of DT use, the cost advantage is that the operational cost is going down with time. And that is the advantage you are achieving if you are using this DT, digital twin method for optimization of your control values. Like see, optimization mode is on and off. During that time, you see that operational cost is going down. In cogeneration, it is basically using of combined heat process where the loss of 11% loss and the useful heat loss is captured using the cogeneration method. And in this method, actually what is happening, you are reducing the waste. And comparing with the 55% or more using traditional generation method, it is clear that cogeneration uses fuel more efficiently. So in the selecting process, there are 2 things are there. You can select either bottom cycle or you can either for topping cycle. For bottom cycle, it is for small cogeneration systems, and topping cycle is for large cogeneration systems. So this is my slide, and this is the basic things which I have just talked on. The 2 things only. One is SCADA, which is very important, and second one is machine learning, because cogeneration systems is just secondary use. I am just described here, but if you see the main things are electronically or instrumentation perspective, it is IoT, SCADA, and machine learning. So machine learning is based on the AI and big data, and SCADA is the advanced version of your DCS instrumentation, and IoT is obviously is the Internet of Things, cloud based. Okay, using the handheld devices, and also you can use your laptop computers or any of the iOS like Android, iOS, anything. So with this, I think the basic things are clear to all of you, that these are the things which will ease our operations, it will ease our work in maintaining a boiler operations much more efficiently on real-time basis without involving much of the manpower and cost saving, and also the efficiency is improved. Thank you.
All right, Dr. Panjal, thank you very much for that presentation. We have several of our participants wishing you a happy birthday. We have one
Thank you very much, sir.
from Prakash, wishing you a happy birthday. Also from Engineer Madaki, from Swat Valley, several people wishing you a happy birthday.
Thank you very much, sir. Thank you very much for your wishes.
Okay. Also, there's one from Abiodun from GNPLC, also wishing you a happy birthday. All right.
Thank you.
Well, let's take a couple of questions, and I'm not sure if this question is for Dr. Prajal or for Engineer Shirley. But let me read it out, and we'll see. Okay, so there's one that says, how do you reduce boiler fuel gas smoke?
Okay. See, boiler fuel gas leak, the leakage control is obviously what I have not said that any technology will stop, will control this, because it is based on the traditional approach. Okay. Only police area. It goes area. So the only requirement is that this system will help to maintain these things on real time. Okay. So process will be same with the conventional process only. Only this human intervention is not required, because it will beforehand it will inform you that something goes wrong in your parameters. Either it will shut off immediately by itself, automatically it gets shut off, or it will warn the operators to shut off before time, before any catastrophe happens. So my thing is like use of technologies to minimize the human intervention to control all the important and crucial parameters before time, on real time, so that nothing happens post incident or post accident.
Okay. So there's another question here. It says, sir, we know that water is very important as far as steam boiler is concerned for steam generation. How can we control and maintain the water quality for boiler efficiency? And that's from Madaki.
See, the water quality, it is basically based on the boiler feed water quality as per the international standards. So before setting up in the plant for boilers, the water quality is always checked before using as a feed water. That boiler feed water sensor will tell you beforehand that quality of feed water as feed water is not as per the parameters. So obviously it will trigger a basically you can say trigger a information to all the concerned operators that you need to check the parameters, because these are the parameters which should be required, but it's not coming at the level. So based on that, they can take up the case, and they can treat this water.
Okay. All right. So there's
Technology only.
Sorry about that. I thought you had finished. There's another question here. I think it's a very simple one from Lamidi, and I say meaning of IoT. I think that's Internet of Things, but you can talk to that.
IoT is Internet of Things. Like there are two things basically. One is IIoT and one is IoT. One is industrial IoT and one is IoT. So IoT, what I'm saying is basically all the applications which you are getting presently in our mobile phones, using the Android or iOS or any type of operating system. If we can just what we are doing, we are using this interfacing of these operating system like Android and iOS with the operating system which you are presently dealing in our laptop or computers like Microsoft or something, or Microsoft or Oracle something, that interfacing, so that it can be carried in your hands, and it be easy to use, not taking all the big equipments with you. Just with your mobile phone, simple mobile phone, you can take all the controls on your parameters on your hand, in your hand, and you can check out if anything goes wrong. You can also control from your mobile phone. That is basically the use of IoT, Internet of Things. Means all things which can be digitized is basically IoT.
Okay. Question from John Obozero. It says, what is the difference between induced and forced draft fans as regard their function? Did you get that?
Hello.
Yeah, can you hear me?
Yeah, I'm hearing, sir.
Okay, it says, what is the difference between induced and forced draft fans as regard their function? I don't know if that question is clear.
Okay. I'm whole. Hello.
Yes.
Yeah.
Did you get that last question?
Yeah.
Okay, maybe it's not clear.
Tell me, sir.
Maybe we'll just have to get the John to restate that question clearly. Another one here from Aditayo, when it says, in your experience, what is the percentage efficiency improvement that can be achieved using machine learning for optimization of boiler control versus traditional controls?
See, in the traditional lot the operational efficiency, I can say in my concern or my experience, it is like it is a jump of 20 to 25 to 30% of efficiency improvement if you use the machine learning or if you can use the IoT also, because the main thing is here is we are getting all details on real-time basis. That is the most important things.
Okay. A question from Shukla Indresh. It says, what's your advice on agro boiler usage?
Means which type of boiler?
Agro boiler usage. I'm not sure if that question is really clear.
In Tripura, it is basically the gas-based boilers, mostly operated by ONGC, Oil and Natural Gas Corporation of India. So see, my technology is not specific to any type of boiler or any type of industry. It is specifically for the boilers where all 5 parameters which are common for all type of boilers, whether small, big, is applicable. It doesn't mean to like it is being applicable only for steam or fire boilers or something like. It is applicable for gas. For gas fire also it is applicable, because we are using in my plant is gas fire. Natural gas, so it works well. Nothing for a concern if you're using any of the technologies which is being embedded in the system and make a part of the process.
Okay. So from Prakash asked this question: what is the basic parameters like hardness of the water used for boiler? How to monitor the ppm of dissolved oxygen?
So basic parameter like hardness of water depends on the contents like lime contents. So which can also obviously which can corrode your boiler's internal surfaces. So in that case, what is happening? You have to you have to change you have to rectify or repair your boiler systems if you are using the hard water in frequent manner. Unless if it is not so hard, if it is not hard water, then obviously your boiler will sustain for some more time. But this technology will not help you in that. It will just monitor and give you a sense that now the time for the.
Okay. All right. So this other question says, you said SCADA is an advance of DCS. We just purchased SCADA for our turbines operation yet to arrive. Are they operating same as that of the boilers? Did you get that question? Hello? Hello, Dr. Pranjal, can you hear me? Hello? All right. Dr. Pranjal, are you still there? All right, so looks like we're having some technical issues, Dr. Pranjal, but while we're waiting for him to come back, can we take just one, an additional poll, one or two, actually? Emeka, are you ready for the next poll? Let's take the next poll. Thank you. So the question is this: what is the capacity and operating pressure of your boiler? And you have 4 options there. Can we quickly do that, please? What is the capacity and operating pressure of your boiler? So Emeka, how are we doing in terms of response?
So so far we have a 99% registered so far. So it's still ongoing.
Okay. So can we close that out and then do the second one? So if you can just give us the results of the okay, good. So 55% of respondents says 10 tons per hour, which is 10 bar. Okay. All right, very good. Let's take the next poll very quickly. The next question. Have you recorded any major accident in your boiler plant in the last 5 years? Very easy question, yes or no? Have you recorded any major accident in your boiler plant in the last 5 years? Yes or no? Very quickly. Okay, Emeka, what's the result of that? No, 82% no, and very few yeses. Thank you very much. Let's do just one more very quickly, just one more poll very quickly before we go to our next presenter. Okay, what are your current boilers feed water treatment challenges? You have 4 options there. Is it difficulty in controlling total dissolved solids? Is it difficulty in maintaining the right pH? Is it fouling of water side or others? Very quickly. The current boiler feed water treatment challenges. You have 4 options. Okay, Emeka, what's the result of the poll? Okay, so 33% of you responded with difficulty in controlling total dissolved solids, and then 36% is others. Okay, I wish we had a way of finding out what the others are, but thank you very much for your responses. Appreciate that. And we'll quickly move to our next presenter. Our next presenter, facilitator, is going to be speaking on opportunities for energy savings in boiler operations. And the presenter will be Ayodele Dada, who is a certified energy manager. He's also the Chief Executive Officer of Stratagem Energy Management. He's an energy conservation manager and a pragmatic advocate for climate change and sustainability. He's passionate about saving energy and helping the global environment, and skilled at providing insights on practical, guaranteed ways to do energy efficiency. So let's welcome Ayodele Dada, whose slides are already showing on the screen. Thank you, Mr. Dada.
Hello, Afolabi. Good morning, everybody, and happy birthday to Dr. Pranjal. Thank you for having me. I also want to thank Engineer Yemi Shoyele for doing a good job earlier, and of course, Dr. Pranjal. And also I want to say thank you to the ETC team for having us, for putting this together. It's really, really a very interesting discourse we've been having since morning. I'll quickly go into my presentation, which is opportunities for energy savings in boiler operations. Opportunities for energy savings in boiler operations. My work has been made a bit easier by my colleagues who have already talked about the boiler as a system, monitoring systems for boiler, how to improve, how to maybe retrofit your boilers with the new technological wave, IoTs, Internet of Things. But today I want to look at boiler efficiency methods, energy saving opportunities for boilers. Of course, we've seen this, so I wouldn't want to bore you. Since the time my presentation will be quickly delivered, because like Additional said earlier, there is a full bouquet of training being prepared to cover industrial boiler systems. So we're just going to go through this just to be like a preamble. So we've already talked about subsystems of the boiler earlier, the burner, the controls, the water treatment to feed water system, the fuel supply system, the condensate recovery systems, and of course, in some cases, the economizer. So this picture is just to give us an overview of what a boiler looks like. The definitions. What is energy efficiency generally? I see energy efficiency as a process or a method where the energy input, the input into that process is reduced, but the output is maintained or improved compared to a traditional system, compared to an older system. Let's do a quick example. An LED, a 5-watt LED or 10-watt LED bulb, compared to a 60-watt incandescent bulb, would give the same output, but the input into the two processes are lower. The input into the LED, it takes a lower energy to give us a better illumination, a better output. What is boiler efficiency? This, I also define this as the efficient operation of all the systems, all other systems in the boiler, because the boiler itself has a lot of systems coming together, working together. All of the other subsystems must be made to work effectively, efficiently to deliver an overall system efficiency. Engineer Shoyeli has mentioned some of those systems and how to do that. So in addition, I feel to really get an effective system working for us, if you're in the boiler house, if you have boiler as part of your utilities, it is dependent on the combustion of fuel itself, effectiveness of the heat transfer, and operations and maintenance. In fact, I always prefer to focus more on the operations and maintenance of the system. So let's dive in straight away. There are two basic boiler efficiency methods, how to evaluate a boiler's efficiency. We have the direct and indirect method. Just like the name implies, the direct method is just to see the heat output over the heat input and get the percentage. That is the energy gain of the working fluid. The working fluid, of course, for a boiler is the fuel, is this water and the steam, and to compare it to the energy content of the fuel. Are we using a low pour fuel oil? Are we using automotive gas oil, AGO? Are we using natural gas? The energy content in each of these gas is compared to what energy the working fluid has gained. And we can express it in a simple way, which is the boiler efficiency is equals to heat output over heat input multiplied by 100%. But the indirect method is talking about the heat loss efficiency, is the heat loss efficiency calculation method. And we subtract all these losses from 100. A fraction of these losses is subtracted from 100 to give us the efficiency of that particular boiler. I have put some formulas there just to simplify it, and I'm sure most of us are asking for the slides. I'm sure Afolabi would speak to that later on. So this is also a graphical representation of the two methods for boiler efficiency calculation. The one is a direct method, is simple. The other one is an indirect method. It's more a bit complicated. It takes into cognizance a lot of losses, the heat losses during the process. I quickly dive into the main discussion for today, which is energy saving opportunities for boilers. The first one, I will run through this and then I will take them one by one along the way. Metering and monitoring. If you execute this, of course, it helps us to have informed decision. Most of the time, we need to have an idea of what is happening in our boilers. And most of the time, we don't have visibility into the boiler. At times, it can look like just a black box when we look at it. And so for somebody who is working there, who is an operator, somebody who is a manager, somebody who is a decision maker around the boiler, you need to have eyes into the boiler. And I think I have a quote for you later on to talk about this. Of course, the next thing is effective maintenance. The maintenance, like I said earlier, is huge. It has a lot of impact. It can improve efficiency for about 5%. And that is huge when you look at boiler, because most of the time, most boilers are operating between 70 and 80%. And you can actually move your efficiency upwards to about 85 and 90%, if not more. Cost tracking, most of the time we don't know what cost our boiler is consuming. At times we consider the fuel cost and we leave the maintenance cost, we leave the inspection cost. At times we consider the fuel cost and we leave the water cost, the chemical cost. This cost tracking would help you to know what are the inputs into my process, what is the cost that I am putting into the process of generating steam or generating power via this boiler. What is my cost per kg of steam or per ton of steam that I am producing? Another area where we can save money or make savings on boiler is water treatment. There is a potential impact on the life of the boiler here when the quality of water that we feed into the boiler is very, very okay. It is good. The water is processed. It is the right quality of water that the OEM has specified. There is every tendency that boiler will last long. I've seen boilers that have lasted 50 years, and I've heard from senior colleagues boilers that have lasted more than 50 years. So we can do that. Another way we can save money or opportunities for saving money in boiler is alternative fuel sourcing. If you have access to natural gas, we all know it's cheaper than diesel, is cheaper than LPFO. We can change the fuel source. Of course, we've mentioned this, my senior colleagues have mentioned it earlier, condensate recovery. I mean, if you need the condensate, the basic thing it does for you is a 1 degree saving. If you the temperature change you want to achieve, if you achieve 1 degree from adding condensate to your water, it can lead to about 1 liter saving on any fuel that you use. So that's to tell you how huge the savings are. At times you need to consider, if you are in an industrial setting when you have gas generators running, do we need to have an independent boiler? Can we replace with a waste heat recovery boiler, a heat recovery boiler? This is another opportunity for savings. Steam traps, economizer, Engineer earlier said that. Another one is the pressure reducing valves or station. This can also help us to ensure we reduce the amount of fuel that we consume in the boiler. Another one that I love in energy saving opportunities is proper installation of pipes and valves. You could be losing up to 5 to 10% on your fuel cost if you don't execute this. Also on the valves, we have situations whereby we insulate the pipes, we don't insulate the valves. The valve is also part of the steam network. Also, fixing of steam leaks and condensate leaks. This is a huge potential opportunity for us. There's a huge potential savings here. I'll quickly go into some details. I want to deal with some of these points in details. And like I said earlier, I have a key point. Most of the people who speak to me or who know me or forums where I've spoken, I always say this: what you cannot measure, you cannot manage. If you can't measure it, then you can't improve it. So these are two salient messages in the energy efficiency world. We must measure. You must measure. And I want to show you a picture of a system. This is an Effimax that is this is a product from Forbes Marshall, showing you critical areas of your boiler, your start temperature, your enthalpy losses, your efficiency, your steam flow in kg per hour, your steam temperature. This is pure visibility. You are seeing everything. You can see this, you can improve it. You are measuring it, you can bring about improvement. This is one of the most interesting solutions I've ever implemented when it comes to boiler metering and monitoring. I want to show you a paid back calculation of one of the boiler monitoring systems I procured in my previous work around 2012. You could see the capacity of the boiler in kg, the two types of fuel, low pour fuel oil and natural gas. Some of the costs are no more. That's why I put the year. These costs are not reflective now. But I just wanted you to see it as it was at that time. And what we can see here is the oil consumption per year is 1.7 for LPFO, 1.8 meter cube for gas. And then the cost saving by implementing with just a 2% saving by taking corrective action on boiler efficiency based on the monitoring system information, by checking your stack temperature, by checking your steam temperature, by looking at the boiler efficiency on the monitoring system, by taking informed decision. The payback on this monitoring system is less than a year as at 2012. I don't know the cost now. That's why I decided to use something that is specific to that particular year. So this is a simple confirmation that by doing monitoring, by doing metering and monitoring, you could make huge savings. And that's the starting point for me. You can do a lot of other things, but this is the starting point. I want to also talk a little bit about best practice for boiler maintenance. I'm sure my senior colleagues have also mentioned some things, but I just want to point out some data. By cleaning your suit, by cleaning the boiler tubes regularly, you could save your boiler some headaches. With only 0.03 of an inch thick suit, you can reduce your heat transfer by 9.5%. So if we do effective maintenance, cleaning of our tubes, we have improved heat transfer. Another one is a 0.18 layer inch thick of this can also reduce your heat transfer by 69%. Another thing we need to consider is the water treatment chemical. This, we need to, like I said earlier, to put the right water quality into the boiler. The blow down, how frequent do we do the blow down? Inspection and repair. Some people now have, for the blow down, they have it automated. So the TDS is measured before the blow down is activated, because you do not need to do the blow down as frequently as you want to. You want to make sure it is based on data-driven decision-making on our boiler system. Like I said, also inspection and repair of insulation. During maintenance, we need to identify and immediately repair anywhere we see that insulation is going bad. Engineer Shirley has talked about safety and also checklists and elimination of steam leak. But let me quickly show you something about steam leaks. A half-inch steam leak, a half-inch orifice steam leak will cost an average of 15 million annually. It depends also on how you use this boiler. It depends also on the type of fuel that you use. But a half-inch orifice steam leak will cost you about 15 million naira. I'm sure some utility managers, some boiler managers, some boiler technicians, some business managers are already thinking, how many leaks are in my factory? How many leaks are in my steam network? we need to eradicate steam leaks. I just wanted to show you the huge potential that you can have in eradicating steam leaks. We've talked about condensate recovery system previously, and I just wanted to mention some of the benefits, the huge impact in terms of costs, the reduction in your water consumption, because you are using the same water that you have used to generate steam originally. You are returning it. That's why we call it the condensate recovery system. Some organizations are, of course, we know the government regulations on effluent treatment, so we can also help us to reduce the cost of effluent treatment. It will maximize the boiler output and the lifespan. I've mentioned this later. And then the boiler feed water quality itself, the water that we are putting into the boiler, the quality continues to improve. In fact, the water from the condensate recovery system has better quality than a freshly treated water that you want to put into your boiler. Like I put in the call out there, without this system, the boiler is not complete. The boiler system is not complete. And such business is cheating itself. It's like you are just pushing your money down the drain. So to wrap up, I would like to talk generally about boiler efficient, energy efficient boilers. A more efficient boiler naturally saves us money. It saves us fuel, and which in turn saves us money. We begin to check, we begin to count how many volume of fuel have we consumed. What does this translate to? How many volume of fuel were you able to save? What does this translate to? And normally, as fuel prices increase globally, this is affecting our bottom line. And of course, CO2 reduction. When we reduce the number of fuel we burn, it helps us to reduce our carbon footprint. And like I mentioned earlier, if you have a natural gas generator that is running in your premises, why don't we install an heat recovery boiler? It saves us money. It saves us the stress of having multiple independent systems, a generator, a boiler, a cooling compressor. We can have all this in a CHP system, a tri-gen, a quad-gen process, and then it will help us to save the world from carbon emissions. Like I said, my notes there, generally the payback period for heat recovery boiler is 3 years, but I have executed a payback for 1 year in my previous job experience. It delivered 1 year saving. Hello?
Yeah, we can hear you.
Okay, I just wanted, everybody was quiet, so I just wanted to be sure I'm not the only one in the room. Okay, so a boiler system also accounts for about 60% of the world's CO2 output, so we can make a difference by making sure our boilers run effectively and efficiently. We can also save a lot from using an economizer. I don't need to overemphasize this, but I just wanted to put a cost to it. With just 5% saving, you'll be shocked. The 5% efficiency improvement can result in a 10-ton boiler. Most of us in the poll said we're using a 10-ton boiler. Over a 20-year period, you can have fuel saving of about 600,000 pounds. I forgot to put this in Naira, but I'm sure that's some huge amount of money. And like we said earlier, boiler monitoring systems. We need to capture, we need to monitor, we need to take informed decision. You don't just want to do things anyhow. Thank you very much. I'm open to your questions.
Thank you very much, Mr. Ayodeji Dada. We would like to maybe close out here as quickly as possible because we promised this was going to be from 10 to 12. I know a couple of our participants had to drop out because they had other appointments to make at this time. There's a notice in the chat section with the link on the feedback. We would like for all of our participants to please visit that link in the chat box to put their feedback, give us their feedback. Okay. Emeka, some are asking that we repost the link because they couldn't click it. Let me see if we can do that right away. You can simply just copy the link into your browser. That would work. So I'd like to thank all of our facilitators, all of our presenters. Dr. Pranjal, particularly, he had to drop off because he had another engagement. Engineer Shirley, thank you for staying with us. There are a lot of questions that we were not able to take live. We will attend to those questions. Your facilitators will attend to those questions. We'll send them out to all of our participants. And I hope you've all learned one or two things from the discussions. I'd like to also thank all of our participants for being here. Mr. Ayodeji Dada, who was our last facilitator, thank you for being so patient, and thank you for that wonderful presentation on energy efficiency, energy saving rather, in boiler operations. Let me hand over to my colleague, Additional, to see if he has any final thoughts for us. Additional, do you have anything to say?
Yes, please. Thank you very much. I just want to thank everybody for hanging in there with us. And I want us to know that this is just like a tips of the iceberg. Like they say that you are one qualification or one skill set away from your next level. So I like to encourage all boiler operators and engineers in the house that you need to get certified, all right? You need to be part of professional bodies. So that is the reason why we have put up these 10 specialized modules that is starting from the 10th of June. You can individually sponsor yourselves, or you can discuss with your organization to get you on board, because it's important for you to be part of professional bodies. There are so many things going on in the world of boilers. In Nigeria, for example, I discovered that we don't have a strong major body that is regulating boiler operators. You know, we have in the Asia, in India, we have in the UK, we have in America, but this is the beginning of a new thing. So each of our training programs for these modules are going to be deployed for 2 days each, 6 hours daily, okay? 2 days each, 6 hours daily. If you look at them, and the cost is 30,000 Naira per module per participant. And if you want to be internationally accredited as a boiler operator and engineer, you need to finish the 10 modules. This certification is going to give you recognition anywhere in the world as a boiler operator or maintenance engineer. That's all for now. If you need to register for the upcoming module, the first one coming up in June 10th, kindly send us an email. The contact is being displayed right there. And I wish everybody well. Have a nice weekend. Thank you very much.
Okay, also before we all leave, I'd like to mention that all of the presentations will be sent to the participants, including the links and contact details for our facilitators in case you need to get in touch with them. And thank you all very much. And I wish you all a good day.
Thank you for having us. Thank you.
You're welcome. Bye-bye.